Right, so we're going to look at 1.5. This will be our last section for this week. And it's on what we call rewriting literal equations. So your first thing for your guided notes right at the top, it says an equation with two or more variables is called, and it's the name of the section, a literal equation. And what we're going to practice doing is rewriting a literal equation. And what that means is basically taking the formula that you have and rearranging it to get a letter by itself. Okay, and I'll show you guys a real kind of simple example, and then we'll do example 1 on the guided notes. So you guys just have to write the two things that are highlighted in yellow. All right, so let me give you an example of an equation. We might look at this equation. Yeah, we're going to do this one a little bit later, but it's just kind of good to show you something right now. So this is the equation distance equals rate times time. That's an equation that figures how far you go, depending on how fast you're going and how long you've been going at that speed. Okay, so you don't have to write this down right now, because we are going to write it down. But what letter is by itself right now? D. D. Okay, the letter D is by itself. Now what I might ask you to do on the test is make it so the letter R is by itself. So what that would mean we have to do is take the T that's on this side and somehow move it to that side. So to do it, we would do it the same way. Let's pretend like you had a number there. If I asked you to get the R by itself, how would you move this times 3 to the other side? Yeah? Well, it's a times 3, not a plus. Yeah, divide by 3. Yeah, you divide each side by 3. Well, in this one, it's not a 3, it's a T. So if I want to get this by itself and put the T on the other side, how would you move the T over to the other side?
Divide by T.
You divide by T. So the formula would be right there. And that's what we mean when we say rewriting a formula. It's just taking a letter and usually moving it to the other side. It's just not a number, it's a letter. Right. It's the same formula. It's just a different way of rearranging it. Okay. So let's try this one. This one says to solve the equation x plus y equals 7 for x. So when you're done, you are not going to get a number as the final answer, like 5. You're going to have a formula. Okay, but right now, the 7 is all by itself on the right. I want to rearrange it so the x is by itself. So can anybody tell me, the board's working a lot better. What's preventing the x from being by itself right now? There's something with it we don't want with it. Yeah?
On the notes, for example, it says solve the literal equation, and it says for y.
Oh, it says for y?
Yeah.
Okay, well, yeah, we could just do it for y then.
Alright.
We'll just make it what your guided notes say.
And then do we write that equation where the...
Yeah. So in the blank line, it says solve the literal equation. You guys have a blank right here. Just fill that in. Okay, so we're going to try to get the y by itself. What's preventing the y from being by itself right now? Yeah?
The x.
Right, this plus x. So we have to get rid of adding an x and put it on the other side. How would you undo adding x? Yeah?
Subtract it.
Subtract x. So you're going to do minus x. Minus x. And what happens when you do x minus x?
Cancel.
This cancels. So that's gone. What do you have on the left side now?
Y.
Just a y. And what would you put on the right side?
Add an x. Or 6x.
Well, first, are these like terms?
No.
No. They're not like terms, so you can't combine them together.
So
You pretty much just have to write down what you have, and
So
that's
would
all
it
you
be
do.
7 minus x?
It would just be 7 minus x. Yep. And that's all you can do. But that's called solving an equation for a literal equation. Any question on what we did there? Yeah.
Did you basically just rearrange the problem and that was it?
I just rearranged it, yeah. Yep. That's all we did.
Is it still possible? Like solving wise?
Well, to solve it, you'd have to know a little more information. Like if I said to you, let x be 2, and then tell me what y is, well then you could fill in a 2 and do 7 minus 2. But for this, that's the last step. You stop right there. Is there another question on that? Yeah?
Are we recording?
Yeah, I hope so. As long as it's working. Yeah.
Does it matter if you write like x equals 7 or x minus 7?
So in this case, 7 minus x and x minus 7 are different. It's kind of like saying 5 minus 2 and then 2 minus 5. They're not the same. There is one other way you could write this. You could do y equals negative x plus 7. That's the same thing. Because the x was negative up here, the x is negative down here. The 7 was positive up there, and the 7 is positive down there. That's the only other way you could rewrite it, but I'm guessing most people would just probably leave it that way, which is okay for now. The bottom one is a better habit to get into, not necessary for this lesson. Let's try example 2. Let me make sure it matches up with what you guys have. So this one says, so yours says solve for x. So we'll just change mine then to make it an x. Okay, so solve for x. Okay, so let me write that. So 8x plus 7 equals negative 5x plus 7y. Well, the first thing we want to do is, if you're trying to get a letter by itself, you need to have all the letters on the same side. So we look at it and say, okay, is there any distributive property we need to do? No. Is there any combined like terms on the same side? No. So is there any adding or subtracting I could do to get all the x's on the same side?
Yeah,
Okay, what could I add or subtract from both sides to do that?
8x.
Okay, what do you want to do? You want to subtract the 8x? All right, you could do that. That's going to give us some negatives. How about if we put all the x's on the left side? How would we do it that way? Add what?
Negative 5x.
So say it again. What would you add to both sides?
5x.
Add 5x, yes. So what this is going to do is put all the x's on the same side. You're not wrong if you want to put the x's on the other side. I just want to avoid negative numbers if I can for now. Okay. So what's negative 5x plus 5x? 0. Nope, 0. That's gone. Those cancel out. Negative 5 plus 5, 0. Okay. What do we have on the left side now? Yep.
13x plus 7.
So 13x plus 7. And what about on the right side? Just the 7y. Yep. Okay, have we done what they wanted? Have we solved the equation to get the x below?
No.
No, but it's better because we don't have x's in 2 spots anymore. Now at least we only have x's in 1 spot. All right? So now we're still at the adding and subtracting step. Is there any more adding and subtracting I can do to eventually get this by itself? Because that's the goal. Solve for x. Yep.
Subtract 7.
Mhm.
7 7 and then do it on 13.
Subtract the 7 from both sides. Now you have plus 7, minus 7. What happens there?
Cancels out.
Those cancel. So we got rid of that. Is there anything still on the left side?
13x.
13x. Yep. Equals. And now are 7y and negative 7 like terms? No. So you pretty much just have to write down that. So what would we put on the other side?
7y minus 7.
Just 7y minus 7. Now, if this was something like 7y minus 2y, then I would say, yeah, we could combine that. 7y take away 2y is 5y. But this doesn't have a y, so we can't combine it. Okay, have we got the x by itself now?
Yes. Or no, so 13.
Yes.
We still have a 13 next to it. Okay, until that 13 is gone, the x isn't by itself. How would you move the 13 to the other side? Yep.
Division.
Yep. So now we're at the multiply and divide step. I agree, it is going to be division. You do it just like that. And what would you divide each side by?
13.
13. 13 and 13. What happens when you do 13 divided by 13?
Cancels out.
This cancels out. What's on the left side now?
X.
Just x. And on the right side, you just leave it exactly the way it is. 7y minus 7 divided by 13. Have we got the x by itself on the left now?
Yes.
Yeah. Then we've done exactly what they wanted. And that's all you can do. So that was a little bit harder than the last one. Especially because we got numbers here that we can't reduce. Okay. Question on that one? All right, let's try. I don't know if you still got a little space under example 2, but let's just try one more like that. Let's call this example. We'll call it example 2b. We'll make this one like example 2a.
On our paper, we have example 3.
Yes, there's an example 3 that we're going to do next.
Oh, okay.
Yeah, we're going to do that one in a second. So if you had a little bit of space in the example 2 box, we'll just put this here. Let's say solve the equation for y. So we're going to have 2y plus 3 equals, let's say, 12x. Let's do plus, actually, let's make that plus 17. Let's make that 17. Okay. All right, why don't you guys try that one for a minute. See if you can get the y by itself. Okay, this one is pretty similar to the last one we just did, example 2a, but I made the numbers a little bit nicer. So when we're done, things are actually going to reduce here. If you get stuck, just let one of us know and we'll come take a look. So this problem is going to be very similar to the last one in terms of the steps you have to do, except I made the numbers work out nicer. So the goal here is to get what letter by itself? Y. So eventually, I want that all by itself. So we're going to follow the steps in SAM to move everything that's not in that box over to the other side. So is there any distributive property?
No.
No, you're usually not going to have that. Combine like terms? No, there's no combine like terms. So adding and subtracting. Is there any adding or subtracting you could do to start to get that y by itself? Yeah, what could you do?
like subtract 17 both sides? Or like no. You
Well,
would
yeah,
subtract 3.
Yeah, we want to take stuff and move it away from this side. We don't want to put more stuff with it.
Yeah.
So we're going to minus the 3 and minus the 3. It is important you line up the like terms. Okay, so 3 doesn't have a letter. That's why I put it under the thing that didn't have a letter. Okay, can anybody tell me what my equation would look like at this step? What would be on the left and then what would be on the right?
2y
2y is on the left. Yep.
equals 12x
Yep, 12x. Haven't done anything with the x yet.
plus 14.
Plus 14. Okay, so now look at it and ask yourself, is the y by itself?
No.
Okay, then we need to keep following the steps in SAM till we get it by itself. We did adding and subtracting. Is there any multiplying or dividing? Yeah?
Y.
Yep, there is going to be dividing. And what are we going to divide each side by?
2.
2. We're going to divide by 2 and divide by 2. Okay, what happens on the left side when we do 2 divided by 2?
It cancels out.
That cancels. And what's on the left side now?
Just y.
Just the y. Now, in the last problem, we stopped at this step and we wrote 12x plus 14 divided by 2, and we left that as the final answer. That's because 13 didn't divide into 7. But look at this one. Does 2 go into both of those numbers? It has to go into both of them.
Yes.
Yes, it does, and we can simplify it. You kind of do this part first. What's 12x divided by 2?
6x.
That's 6x.
And then
Copy your plus sign down. And then do it again.
7.
What's 14 divided by 2?
7.
7. Just 7. Because there was no x on the 14. And that's as simplified as you can make your final answer. Okay, if you leave it as 2x plus 14 all divided by 2, that's okay. But really, anytime you have a fraction where you can divide the bottom into the top, you should simplify it. So let's just make up something like this. What if you had 15x minus 9 divided by 3? Does 3 go into 15?
Yes.
Does 3 go into 9?
Yes.
Okay, we can simplify it. What's 15x divided by 3? And what's negative 9 divided by 3? Negative 3. Exactly. That's how you'd simplify it. Okay? But that only works if this number goes into both of them. So if we go back and look at the last one, does 13 divide into 7?
13, no.
No. No. This, first of all, this number at the bottom would have to be smaller if it was going to go into the number in the top. So 13 does not divide into 7. No. So that's as good as you can do. Any question on that one? Okay, let's try this one. I think you already have it printed on your notes today. So it says that you own, like, your house, your property. It's a rectangular lot, and it's 500 feet deep. Okay, so like this is the road. That's what that yellow line is on the right-hand side on the street. So the road, and then your grass goes back 500 feet from the road. It says that the area of your property is 1,000 square feet. Okay, that's this. That's how much grass you have, right? All the area of your property is 1,000 square feet.
100,000. Yeah.
100,000, yeah. And it says to pay for a new water system, you have to put in like a new pipe in the front of your yard. Okay, but since that's on your yard, you have to pay for the new pipe just on your section of the grass. Okay, and then the neighbor will, pay for the rest of it from there. You have to pay $5.50 for every foot of pipe you have to replace along your front yard. So what we have to do is figure out how much it's going to cost to put in that new pipe. So the first thing it asks us to find is what's called the frontage, which I've labeled. It's just the right side of the rectangle if you think of that green rectangle as your grass. Okay? So we have to find out basically how long is the front of your yard.
200.
Well, that's what we got to figure out. What piece of information did they give us about the yard?
1,000 square feet and 500 feet deep.
The area is 100,000 square feet. Now, the shape of your yard is what?
Rectangle.
It's a rectangle. So does anybody remember the formula for the area of a rectangle?
Is it A plus B equals C?
So that's like a perimeter. That would be maybe like a triangle. Could be a perimeter of a triangle. You want to remember?
Isn't it width times length?
L.
Yeah.
No, yeah.
Yeah, L times W or W times L. Yep.
Length, width, and height.
So there's no height of your yard
Yeah.
because it's just flat. But yeah, so it's length times width. So your formula, if you just write it with all letters, area is length times width. Now let's figure out, what are we solving for in this rectangle? Like there's something we already know, and then there's a letter we're solving for.
W.
We're solving for the W. So let's do like we've been doing. Let's get the W by itself, because that's what we're going to solve for. What's next to the W that we don't want? The L. How would you move, when it's a times L, how would you undo times it? You would divide. And what would you divide by to put the L on the other side? L. And divide by L. So what's L divided by L?
Cancels out.
It cancels out. We just get a 1. So what's on the right-hand side now?
A divided by L.
The right side.
Oh, W.
W. 1W or just W. So now you've got a formula for W, which is exactly what they want you to find. What's the formula for the width? It's the what divided by the what?
Area.
What's the area divided by the length?
The length. Now we just have to look up these two pieces of information and see what they are. Area. What's the area?
100,000.
100,000. So if I need a calculator for this. So 100,000. And then it says area divided by length. What's the length of your yard?
500 feet.
500 feet. That's the length. Length is the long side. So the length is 500 feet. And if I divide those two, it's going to give me the...
200, I think.
Well, what's it going to give me first?
The width.
It's going to give me the width. So yeah, I think it's going to be 200. Yep. So we have 100,000. We'll just double check it. Divided by 500. And that gives you 200. So 200, that's this. That's the width of the front of your grass.
And then we'll multiply that by 5.5.
Yeah, so let's write that first. So the width is 200. And what's the unit on the 200?
Per feet.
Per feet, right? So it's 200 feet. And that's the width of your yard. So that's part A. Find the frontage, which just means the width. I would label that in case you didn't know what that word meant. Now part B, it says, how much do you have to pay to replace that pipe in the front of your yard? All right, so we know the width of the yard is 200 feet, and we have to pay how much for each section of pipe by the foot?
$5.50.
We've got to pay $5.50 for every foot of pipe we replace, and we have to replace 200 feet of pipe across the front of the grass. So you know it's 200 feet, and you're going to pay $5.50 for every foot. So what do you think you'll do with those two numbers? Yeah?
Multiply them.
Yep, you're going to multiply them. So this is the cost for the water system, or to replace the pipe, whatever they said. It's 200 feet times $5.50 for every foot you have to replace.
You would get 1,000.
1,100.
Is that what it comes out to?
Yes.
2,000
No, 1,000.
So 1,100.
times 5.5 is $1,100 to replace that pipe. Right? So this problem did a few things. First, we had to solve the formula for the letter, and then we just had to plug in the information they gave us in the problem to calculate a number. Okay, and if you didn't know the formula for area of a rectangle on a test, I would tell you that. But again, you could also have a reference sheet, so you could just put it on your reference sheet. Okay. Question on example 3. Okay, so the last 2 examples are going to use some formulas. One of them I already showed you, but they're going to be formulas that involve temperature, interest, and distance. Okay. And we're going to practice taking one of those formulas and either plugging a number into it and using our calculator to figure something out, or rearranging the letters in the formula. Okay, so here's the first one. This is a formula that converts between, it takes a Fahrenheit temperature and it converts it to a Celsius temperature. So like if you said, the temperature today, let's say it's like 65 degrees out. Okay, what would that be if they were talking about it in a country that used Celsius? Well, you'd fill in the 65, and it's in parentheses, so you minus 32 from it. And then you multiply by this number in front, that's 5/9. So if the temperature here was 65 degrees, they would say in Celsius, it's a little over 18 degrees, okay, in Celsius. All right, so that's one formula that we'll take a look at. Does everyone have that first formula? Okay, the second formula is I equals PRT. I think you guys have everything filled in there except what goes in the box. And this is a formula to figure out, I don't know if you can read that clearly. It says I equals PRT. P times R times T. So this is a formula to figure out, like if you leave your money in the bank, anyone ever do that? Like you put money in the bank, and then like when you check on it, sometimes you have a little bit more in there than when you last checked it. It might be like 5 or 10 cents more, or if you have a lot of money, it might be a little more. But this is the formula that they use to figure that out. It's a little bit simplified, but it's pretty similar to the formula they would use. Yeah.
About the bank, they do that because they pass your money around. That's the reason why. So.
Yep, exactly. The bank does it is basically saying thank you for letting us hold your money, so then they can lend it to other people, like if they want to buy a car or buy a house. That's how the banks get money to do what they do.
Yeah, but that they would just say give you a little more than you had before that.
Yep, give you money. Yep. Yeah.
But tell me, why do they use Fahrenheit to calculate it?
Why do they use what?
Fahrenheit, like.
Why do we use Fahrenheit?
Yeah, no, to calculate how much money you get back in the bank.
Well, these are 2 different formulas.
Oh.
So the first one is temperature, and then the next formula is for simple interest.
Okay.
So we're looking at we're going to look at 3 common formulas. So one for temperature, one for interest, and then the last one I already told you is the distance formula. And that's distance equals rate times time. Okay, the bottom 2 are ones that we use probably a little bit more in this class because they don't have that like fraction with parentheses. That complicates it a little bit. Not too bad to just use your calculator and convert the temperature between Celsius and Fahrenheit. But these 2 will do a little bit with rearranging. Right. Does everyone have that last example of the distance, the rate, and the time? Right, so let's try example 4. Let's see if it matches up. On my notes, it says to solve for R. Is that what it says on yours? Okay. So let's write down what the distance formula is first. What is the distance formula? Distance equals?
R T.
Yeah. And what are you doing with the R and the T, even though there's no symbol there?
Multiple.
Yeah, you're really multiplying. You don't have to put the symbol in. Now it's asking us to solve for R. Okay, is the R by itself?
No.
No. What's next to the R that we don't want there?
T.
The T. And it's multiplication.
And divide.
So, yep, we're going to get rid of multiplication by dividing. And what would you divide by?
T.
T. And T. Okay, on the right side, what happens when you have a T divided by T? It cancels out. So now all you have is R equals, and what's on the left?
D over T.
D over T. I didn't use the blank. I didn't use this to write it. That's fine. You just have to get the R by itself. So the speed that you go is the distance you went divided by the time it took you to go that distance. So if you went 60 miles and you did that in 1 hour, 60 divided by 1 means you were driving 60 miles per hour, 60 mph. Okay. Questions on the part where we just get R by itself? Okay, so the next one says to use that formula and figure out your speed. Okay, rate is speed, how fast you were going. To use the formula to calculate R, what are the two things you need to know? Yep.
D and T.
You need to know the D and the T. Let's look at the two numbers and see if we can figure out which one is which. 310 miles. Is that D or is that a T?
310 miles.
Yeah,
That's D.
that's D. That's a distance. So 310 miles is distance. You drive for 4.5 hours. That's a T. So we're going to take the two numbers, the D and the T, and we're going to fill them into our formula. Okay. So what? I'll try to leave that up there. What's going to go in the top of our fraction?
310.
310, because that's the distance, divided by what's going to go in the bottom?
4.5.
The time, which is 4.5. And what's that going to, what letter is that going to give us?
T. R.
R. That's going to give us the speed. So let's just use our calculator for that. 310 divided by 4.5 is about, let's round that to 1 decimal place. What would that be if you round to 1 decimal place? 68 point what?
16.9. Right?
You said 16.9?
No, 68.
Oh, 68.9, yeah. So 68.9, and now we need a label on it. Think of like speed in your car. What was the
Miles per hour.
this is miles per hour. So 68.9 miles per hour.
Wait, I think it's 68.
But you should probably round that because normally it's not.
We just used our calculator. What's that?
You should round it because normally, like on the speed meter, it's not gonna tell you decimals. It's probably just gonna tell you like the actual speed.
Yeah, it might just, the car is probably going to round that off if you have like a
Like
digital
it's
display.
telling you 65 miles per hour.
Yeah, so we can round, I would say, even though you might not see that on your car display, we'll probably go to at least 1 decimal place when you write your answer. Yeah. Just because sometimes we might do things that need at least 1 decimal place. So it's good just to practice it, even though your car might not do it.
I got 91.1 repeated.
So when you type in 310 divided by 4.5, 68.8.
I got 9.1.
I'm not
Oh,
sure.
I did 410, not 310.
Oh, 410, okay.
Oh, I see.
Yeah. I was gonna say, yeah, I'm not sure. Probably used the wrong number, but yeah. All right, let's look at the last question. So it says you're depositing $5,000 in an account that pays simple interest. Okay, so now we know what formula we're using. So look back at your notes.
I equals PRT.
Yep, I equals PRT. And we got to figure out what all these things are. It says after half, or 0.5 of a year, the account had this much interest. We're going to calculate the rate. So if we're going to calculate the rate, that means what letter are we trying to solve for in this formula?
R.
R.
Yep, we're going to try to solve for the I. So that means we need to fill something in for the I, the P, and the T. So principal, in case, I don't know if I said that here, but principal, that's basically the amount of money. I should have said that. So principal is how much money you put in the bank. So reading this one, what's the amount of money that we put in the bank?
5,000.
5,000. So there's the principal. Let's keep reading. How about 1/2 of a year? What's that 1/2 going to be?
6 months.
We're going to leave it as 1/2 because we have to make sure that the time is. Time always has to be in years when we do it. So, what letter is the 1/2?
T is half.
That's T.
Or
And now the account earns $162.50 in interest. So it kind of tells you. But what letter is the 162.5?
I.
That's the I. Okay, so let's fill those numbers in and see what we got. So the I is 162.5. P is the principal. That was 5,000.
Times R.
Times R, we don't know what the R is. And then times T, which is 1/2.
or is it half?
Or 0.5. Yep, you could do it that way too. And what are we trying to get by itself?
R.
Yeah, I'm going to try to get the R by itself. Now, on the right-hand side, we're multiplying something times something times something. Think about this.
5,000.
What's 1 times 2 times 3?
6.
6. What's 2 times 3 times 1?
6.
So when I multiply 3 things together, does it matter what order I do them in? No. So I need to multiply these 3 things together. So instead of thinking it like that, let's think of it as 5,000 times 1/2 times R. All I did was change the order that I multiplied them in because there's 2 things I can multiply together and I wanted them next to each other. So what's 5,000 times 1/2?
2,500.
2,500. So 162.5, and then 5,000 times 1/2 is 2,500. And what's still next to the 2,500?
R.
Still have the R. And now we're at our last step to get R by itself. Yep, because this is being multiplied, 2,500 times R. So we're going to divide. And what are we going to divide by? 2,500. Okay, definitely going to need our calculator for this one. So what am I going to type in on my calculator to get my answer?
2,500 divided by 162.5.
Okay, tell me exactly what order I should press the buttons in.
2,500.
No.
That's in the bottom.
162.5
162.5, yep.
divided by 2,500.
Divided by 2,500. Okay, and it says the answer is 0.065. And that's what you write down. 0.065. And what's that equal to? What letter?
R.
R. And those are the 5 examples for today. Any questions or any example anybody needs me to put back up on the board for a second? Okay, so the homework tonight, okay, is the 1.5 worksheet. There is a review that covers these topics on the test online. So if you want to do the test review, that's one, let me just double check it. The test tomorrow is on 1.3 part 1 to 1.5. If you want to do the review guide, you can. And you could use the review guide on the test, but the review guide is going to be extra credit. So the homework is the 1.5 worksheet, but the review guide is extra credit if you want to do it. There's one problem on the review guide for every problem that's on the test. The only difference is the numbers have been changed, but they're the same questions on the review guide. So even if you don't want to do it for extra credit, you might want to look at it to study because it's going to tell you exactly what's on the test.